Okay, this is where we left off last time, yesterday. Any questions from yesterday's class? Okay, let's continue then. This was our first C++ program. We didn't say much. It is very similar to C programming language. We said that there should be one main function. This main function is called by the operating system. Whenever you run a C program, compile C program, the operating system calls. Why are people late? Why are you guys late? Why are you late? Okay, so this is our first C++ program. We said that it is very similar to C. I didn't show you many new stuff. The only things that are new maybe this using stuff. I didn't talk about it. C out and C in statements. Those operators, stream insertion and stream extraction operator, and that was it. The rest of them is exactly the same as C programming language. Okay, but I didn't tell you anything about object-oriented programming. In this slides, you don't see much about the object-oriented programming yet. We are just trying to tell you how the environment of C++ development works, how you compile stuff. As I said before, I didn't introduce many new stuff yet. Okay, so that was easy. As I said before, I am not going to tell you anything difficult. All the things that I am going to tell you will be easy, but I am going to tell you lots of stuff. If you put all of them together, it kind of makes it difficult without making practice. Okay, so whenever I tell you a new thing, you should practice it yourself. Write your code and test it yourself. See if you understood it right. Sure.
Can we come one slide back? Can we use C in stream extraction operator number of languages? Instead of this, can we make this number of languages stream insertion operator C? Can you make it like that?
You mean, and let's say I have an integer.
Variable name.
I have an integer A. You want to do A C in, something like
Not extraction operator.
C out.
Insertion operator. No.
Yeah, or you want to do the same thing here too. Or you want to do C in, right? No, the answer is no. Because, I mean, this is order dependent. A plus B and B plus A produces exactly the same thing, but this one doesn't produce the same thing as this one. Okay? So operator ordering is important for the stream insertion and extraction operators. Okay? So, I mean, as in the case of, I can write this, order is important, and some people read this as A equals to 2. It is definitely a wrong thing. This is not equality operator. This is not A equals to 2. This is A gets the value of 2 or A assignment 2. Okay? If A equals to 2, then 2 equals to A, right? But we know that this doesn't work, right? This is not meaningful. This is meaningless. You are trying to change the constant value with the value of A. So this is definitely wrong. The same thing happens here. C and A, this is okay, but A, C, N is wrong. You can't do that. Okay, so that's a good question. You might say, well, it's a simple question. Yeah, well, it's a simple question, but it lets me tell you about this kind of stuff. Okay, ask questions, be curious about this kind of stuff and test it yourself. and see what kind of error messages you are getting. Okay, good. Any other questions? Let's move on then. We compiled it this way, and I looked at some of the compiler switches, and I told you read about the compiler switches yourself from the manual page, from the other sources. As I said, there are many of them. By the way, to be able to use the C++11 compiler, you need to specify the switch. My standard is C++11. Otherwise, C++11 features will not be available for you. You will get compilation errors. Okay. And let's continue. C++ identifiers are exactly the same as C. Okay. C++ identifiers and C identifiers are the same. The rules are the same. Identifier, as the name implies, identify things, right? We need identifiers for the variables. We need identifiers for the function names. We need identifiers for the struct names, class names, and etc. So the rules for the identifiers are, we are case sensitive again, and you cannot start an identifier with a numeric character, and etc. You know all of those. On top of it, these are the rules, okay? On top of it, we say that choose your identifiers with meaningful names, okay? Alpha 1, 2, 3 is not a good identifier name, variable name or identifier, okay? Function 1, function 2, function 3, they are not very good function names, identifiers, okay? Choose meaningful names. If a function does adding, just call it a function sum, something like that, okay? If a variable keeps the index, then call it I or index, okay? Variables are like in C. Whenever you declare a variable, let's say I have a function that returns an integer, name is f. When you say I have a local integer a and b, okay, and I have a local float, okay, let's say f. F is not a good name because my function name is f, okay, let's say d, okay. So many stuff. Memory is like a linear space. If it is linear, then I can maybe show it like a set of boxes like this. Let's say this is our desk number, some hexadecimal number F2B1, okay. So compiler says that I am going to keep this integer a here, integer b here, float the here, okay. So this is what's happening. Of course, the size of integer a and b are the same, but they are different from size of float d, okay? They might be different depending on the compiler and depending on the processor, okay? For a and b, it might be 4 bytes. For d, it could be 8 bytes. It depends on the, as I said before, the compiler that you are using, the switches that you are using, also the processor that you are using. But memory is something like a linear space, and the compiler can place your variables anywhere in this allowable linear space. Sometimes it might say that, okay, I'm going to give some space and this place will be empty, okay? We don't have much control about spacing of the variables. It is done by the compiler. Okay, so variables are like that. Again, nothing new here. And these are some of the examples for the variables. As in C, we have short integers, just 2 bytes. Integers are 4 bytes. Long integers are 4 bytes. Floats are 4 bytes. See, float and integer are 4 bytes in this case. Doubles are 8 bytes, etc. Long doubles and characters are 1 byte, and booleans. Boolean is something new in C++. We don't use integers to represent the logical values, true and false. Remember in C we have 0 and non-zero for true and false, right? In C++, that's available, but we don't prefer that. We prefer this new type, okay, variable type Boolean, and it can take just two values, true and false. These are constants, C++ constants, okay? By the way, maybe they told you that in C, okay, we cannot know the size of an integer without asking the compiler the size of the integer. That's why we have the size of operator, right? Size of is an operator. It's not a function, okay? It's an operator. You will say, what is the size of integer? And it will tell you a number, okay? That's the size of integer for that compiler and for that computer. And your integer size might change from computer to computer, right? From processor to processor. Then why are we giving you all these numbers then? I mean, who told you that integer is going to be 4 bytes all the time? Well, these are just, I mean, this is directly from the book. It has an explanation. See, it says that these values here are only for sample values, right? Just to give you a general idea. So the precision, size of the integers and doubles and floats and etc. It might change depending on your processor, operating system, compiler switch, and etc. Okay, so C doesn't guarantee the size of integer. It's going to be 4 bytes all the time. Okay, if you have a 16-bit computer, your integers are going to be 2 bytes most of the time. Okay, so that's why, as I said, don't write any code that relies on that integer is going to be 4 bytes all the time. If you need such assumptions, you are doing something very sensitive about the memory sizes, okay? Then C++11 says that these are C++11 new introduction of new fixed width integer types, okay? Then use these types. C++11 says that if you need your integer to be 4 bytes, then use this type, int32t. Okay, int32t, it guarantees that it's going to be 4 bytes, whatever your processor is, whatever your operating system is, doesn't matter. It's going to be 4 bytes all the time. If you need your integer to be 8 bytes, then use this one. Okay, these are all integer types. As I said, this is not available in the previous versions of C++. It is available after C++11, including C++11, of course. Okay, good. Of course, I mean, then you might ask, why don't we use this, okay, all the time instead of our regular integer? Anybody has any answers for this? Backwards compatibility is something, yeah. I mean, if there is a code, if there is some code written before, like 10, 15 years ago, of course they didn't know about integer 32s. I have to be compatible. But if I am writing new code, C++11 code, why don't I use this one all the time? That would be nice, right? Yes. Explain it again. What do you mean according to the capabilities? And say it louder, everybody can hear.
It knows its capability, so it decides whether it should be 4 bytes or 8 bytes.
Well, I mean, if this is available, then I am capable of representing the integers by 4 bytes, right? So I am capable of it. Why don't I use it all the time? Yes?
Like maybe the default is 2 bytes per integer and it's more efficient for that specific architecture.
What do you mean by default?
The operating system.
By the okay, by default maybe you mean the processor is processor as the processor architecture says that I am going to use 2-byte integers. And if you like to make your integers 4 bytes, that means what? You are not going to use the processor's addition, multiplication, and other arithmetic operators. You will have to implement all of your integer arithmetic yourself, because the processor cannot help you anymore with the 4 bytes. Processor is a 16-bit processor. It's an old processor, okay? 32-bit or 4-byte integers are not possible directly with the processor, because if it's a 16-bit processor, it represents its words by 2 bytes, and if I can represent my integer with 2 bytes, that would be a very, very fast C code, okay? But if I am saying that my integers are going to be 4 bytes, then your compiler has to do lots of other work to make multiplication between two 4-byte integers, and that's going to make your whole C program slower, okay? So it is better to use these integers if you really don't need fixed size integers, okay? So again, to be able to use these, you need to specify your compiler that I am going to compile this program with C++11 standard. Otherwise, you will get error messages for these, okay? You will get error messages for these. By the way, these are fixed with integers. We are not talking about fixed with floats or doubles. These are for integers only. Okay. Yeah, well, we did not look at this precision stuff. Integers and longs, they don't have the precision, but they have their size range. This 4-byte integer can range from minus 2 to the power 9 to plus 2 to the power 9, something like that. Exactly all the integers between these two numbers. But a float can change from, okay, well, is this a small number? It is very close to what? It is very close to 0, but it is not 0, right? And it says that I can represent a number that close to 0, and with the 8-byte doubles, okay, I can get very close to 0, but I cannot do this. I cannot get any closer to 0. I cannot do this, okay? And the largest I can do this. Of course, the smallest number would be minus 10 to the power 308, okay? What is this then? What is 15 digits? What is this number? This is the 10 to the power 308. This is a very large number, right? But how about this one? What is 15 digits? I mean, this one says that my double can have more than 300 digits in it, right? That's what it says. How about this one? What is this 15-digit precision? What is the difference between this 300 number and this 15? Yes?
We have to use another notation to show this number, this big number.
Okay, and what is that notation?
I don't know the name of it.
Okay, well, my question still remains. I mean, what is the 50 and what is this 308? That's my question.
The value will have
What?
the value will have at most 15 significant digits.
What is 15 significant digits?
Like 15 meaningful digits.
15, yeah, okay. 15 significant, or let's look at this one, 7 the significant digit. I can represent a number that has 38 decimal places, right? But only 7 of them I will know, okay? Whatever number I represent is going to be 1, 2, 3, 4, 5, 6, 7, and the rest of them will be assumed as zeros, right? So I have total of 38 digits here. Only 7 of them I can represent, rest of them I will assume is going to be 0. Or if I'm representing something 0.000 dot, dot, dot, dot, and the last 7 is going to be non-zero, can be non-zero digits. That's the precision. That's how you represent your floating point numbers, right? Exponents and mantissas, right? So you represent a double or float in 2 parts. This one, okay, will be the exponent, and this one will be the mantissa, right? I can put, in this case, I can put 7 digits in here. 1, 2, 3, 4, 5, 6, 7. And I can put this 38 in this part. So it's going to be something to the 38. That's why I can fit 4 bytes. I mean, how can you compare this number with this number? This number has only 10 digits. This one says that I have 38 digits. They are both occupying 4 bytes of memory, same space, right? How could this happen? Well, I mean, I am losing lots of information in this case. I am storing only 7 significant digits. The rest of them is going to be ignored. That's why they say that floats and doubles are only approximate, okay? They are not going to represent precise stuff, exact stuff, okay? When you try to represent 1.0 over 3.0, it's going to be only approximate, okay? It's not going to be exactly the rational number 1 over 3, okay? It's going to be approximate. That's why they say that never represent money using doubles or floats, okay? That's the rule. Because if you represent money with doubles and floats, every time you make a calculation with your money, you are going to lose some value, okay? And that's not going to be bad if you are doing billions of money-related calculations. For money, we use integers. Well, you might say that integers are too small. Well, I mean, for the money, you can only say, I have 96 liras and 25 grosh, right? There is no such thing as 257 grosh, right? It is only 2 digits. So you kind of solved it, okay? So if I represent everything by integers, the lira part and the grosh part, right? Then I should be fine. I should be fine. Okay, yes. Well, I mean, you can understand it in a very okay. So you are saying that integers is 4 bytes and long is 4 bytes. Well, what's the difference? Well, I mean, in this case, there is no difference. Okay, but this is for a 32-bit computer, okay? For a 64-bit computer, it might be integers are 4 bytes and longs are 8 bytes, okay? With the 16-bit computers, integers used to be 2 bytes and the longs used to be 4 bytes, okay? Again, I mean, that's a good question too. Why are they the same thing? I mean, if they are, I mean, what the book say? I mean, don't take these numbers as literally. These are just to give you some ideas, okay? If you like to know the exact value of your exact number of bytes that you occupy in the memory, just look at this stuff, okay? See, you don't see any shorts, integers, longs, and double longs, and etc., right? Okay, it always says that 8-bit integer, unsigned 8-bit integer, and etc. You are going to look at the integer and floating point number representations in some of your courses. Hardware courses, I believe, they told you how the floats are represented in 101, right? They did. So you know about that. So, I mean, just try to see what's going on when you make an integer with your C program and try to see what kind of binary values in there, or make a double, try to see what kind of binary values in there. And you know how to do this kind of programming using your pointers. Okay. Other new stuff with the C++ 11. Okay. I like to say stuff like, let's say I have a function name is, let's say, sine, and 3.0. Let's say I don't know what kind of what kind of type sign is returning. I don't know, but I like to have a variable of that type. Then in that case, in C+11, you will say, automatically determine the type of this variable for me by doing this. Okay? It says that I am going to call this function sign, pass this argument, 3.0, okay? And I am going to declare a variable name v. The type of v will be whatever sign is returning. What is sign is returning? Sign returns double, right? So the type of v will be double. You might say that, I mean, what is the usefulness about this? Well, for the case of sign, it is simple, but we are going to see some functions later whose return types are difficult to remember, difficult to type, etc. So instead of typing all those names, making our program crowded, we write something like this. I don't care about the type of x, actually. It is whatever this expression returns. Okay? So that's one new stuff from C++11, auto. Okay? And another one is similar one. You say that I don't know the type of y. I like to have a variable named y, okay? And its type will be exactly the same as this expression's type, x times 3.5. So determine the type of that expression, the declaration type of it. Now my y, the variable y will be that type, okay? Two useful, helpful stuff from C++11. Well, we were happy in C without these two mechanisms, but they say that sometimes it gets to your nerves that you need to remember lots of different types of expressions and etc. And I don't care, actually. Whatever the type of that function is, I'm going to use it. Okay?
Can I ask a question?
Sure.
What if we don't need to remember the type of auto?
What if?
What if we need to remember the type of auto? For example, I don't know, a function return the value, we don't remember it, we use auto, but we need it, but we need this with y for...
Well, I mean, this is not secret. Just look at the definition of this sign from the header file. Well, I mean, this is not hidden, right? I mean, all you're saying is that whatever that sign is returning, I don't care. It could be double, integer, some other variable. Whatever that type is, v has to be that type. Okay? I mean, if you are curious about what sign is returning, just look at the definition of it in the header file.
Can I do this, for example, sign returns double and y has the value of double, and can I add it to another double, and compiler will be okay?
Sure, yeah. Well, this is no different than for the produce code. If you look at the assembly code that you produce, this is no different than, this is exactly this. This will produce exactly the same. This is produce exactly the same code as this. Okay. These are exactly the same thing. Okay. The thing is that as a human being, when I'm writing this program, I have to remember, I have to know that sign returns a double, and I do this. This one says that, no, I don't want to do that. Just figure that out for me. If it is very important for you that v has to be a double, and you are going to do double-rated stuff, then maybe you should prefer this way, because it looks like double is important for you. Okay? If it is not, then choose this way. Okay, good. Any other questions? Simple syntactic sugar. Okay? As I said, we were happy with our lives in C-style definitions. This one doesn't make new things that are impossible with C. Well, I could do the same stuff in C too. I just type a double in there. This one said this is a little bit easier, right? Assignment is the same as before. Again, this is assignment. Assignment says that, okay, whatever on at the right hand side, okay, get the value of this right hand side and assign it to the left hand side. This is R value, this is L value. Okay, L value, okay, left hand side. L value, it has to be something assignable. Assignment statements work that way, okay? And R value should produce some kind of a value, okay? The book says R values must be variables, okay? Well, maybe let me put this variable in quotes, because sometimes it doesn't have to be a variable. Remember, I can write stuff, PTR, guess the value of 2. Well, I mean, PTR is a variable, but dereference PTR is not a value, right? Dereference is an operator, okay? And when you dereference a pointer, it gives you a memory address. And I am saying that put 2 to that memory address, right? Okay, so that's why this is in quotes. L values must be variables, something that is assignable. L values could be an expression, including variables and constants and named constants and literal constants, etc. So again, I didn't say anything new. This is the same as C. Okay. Again, don't read this as distance equals to rate times time. No, this is distance gets the value of rate times time. This is not equals. This is not equality. It is assignment. Okay? It is assignment. Some languages, they use this operator for assignment. Okay? A gets the value of B. I think it would have been better if we used A gets the value of B like this. This would have been a better operator, like less than sign and the dash. It's like just the opposite of the arrow operator of the pointers. This would have been better, but the problem with this one, we use assignment so much, instead of pushing 2 buttons, these 2, and these are difficult buttons too, they decided that let's use that equal sign to make the assignment, okay? So you are not going to read distance equals rate times time. You are going to read it as distance gets the value of rate times time. Okay. Good. As before in C, shorthand notations are available. Plus assignment, minus assignment, okay? Whatever is available in terms of operators, they are all available in C++. By the way, remember the C in and C out? When we say C in, just print this 2 on screen, okay? That's what it says. This operator, this stream insertion operator, we didn't have it in C. But this operator was available, okay? The meaning of this operator in C is what? Binary shift operator, left shift operator, right? When you say shift this 8 2 bits to the left, in effect, you are multiplying it with number 4, because shifting this number by 1 to the left multiplies it by 1, and shift it 2 times, it multiplies it by 2. So what is 8? 8 is 0, 0, 0. This is 8, right? Let's say I have 8-bit number. If I shift this to the left 2 times, it's going to be, okay, it's going to be 0, 0, 1, 0, 0, 0, 0, 0. Is that correct? 1, 2, 3, 4, and 1, 2, 3, 4. And this makes what, 64? No, this makes 64, 32, no, 32, yeah, this is 32, okay? So the meaning of this operator is, left shift is, in C is left shift by 2. And we have right shift available too. If I right shift 8 by 2, it's going to divide it by 4, okay? These are binary operators, okay? Bitwise operators. Sorry, it's not binary, but bitwise operators. And bitwise operators work this way. Well, aren't these operators, left shift and right shift operators, available in C++? The answer is yes, they are available. Yeah. Then how come the compiler can handle both this one and this one? I mean, this is valid and this is valid too. Okay? I can say, okay, I can say integer k gets the value of 8 left shifted by 2, and I can at the same time say this one too. Okay? C++ can handle both cases. The key to this technique is overloading, because this operator is overloaded. Overloading. Overloading means that you give another meaning to an operator, available operator. And we have been using this technique all along in C2, because in C I can write this 2 plus 7. It is easy, it's integer addition, but I can do this thing too. This is double addition. Double addition and integer addition, they are very, very different, right? Integers are represented simple, straightforward way. Remember how the doubles are represented? They are very different, okay? This operator works very differently from this operator. This is integer addition, this is double addition. This is already overloaded in C, and C++ says that, okay, overloading is there. I am going to overload this operator now with a new meaning. I am not losing the old one, but I am adding a new meaning, okay? I am not redefining, I am overloading, okay? Overloading is something that we do in C++ a lot, but C uses overloading. Well, it doesn't make it available for us to overload any operators, but in C++, that mechanism is available for us too. We can overload operators. We can give new meanings to operators, okay? And that's what they did. How does the compiler know that this is left shift and this is stream insertion operator? By looking at the types. Cin has a very different type than this integer, okay? Cin has a very different type than the integer. No, nobody asked me this question. Usually people ask this question coming from the C world. I mean, in this case for the printf, I am telling printf function that I am going to give you 2 strings, then I give 2 strings, right? How about this? I mean, when I look at this line 6 and 7, I am not telling the stream insertion operator that I am going to give you a string, right? I just give a string and it figures it out, okay? And the same thing with the scanf too. In scanf, I said I am going to get a double decimal value, decimal integer from the standard input, but with the cin statement, stream extraction statement, I don't say the type of the thing that I am reading. The compiler can figure that out by itself by looking at the type of this number of languages variable. Okay? So in C++, usually our functions are very type sensitive. Types are important. In C, most of the time, there is a way of ignoring the types. Okay, I don't care what type it is, I am going to run this, etc. Most of the functions in C++, almost all of them, okay, they check their types. If the types are not right, they will not run. But in C++, okay, in C, I would say, for example, this function f, it can take anything that it wants, okay? No type checking will be performed for such a function. You can send any parameter that you like, and the compiler will be okay. Okay, maybe I will return to these topics later. Okay, so that's the difficulty with the C++. It is trying to behave like the C programming language, but it has to be an object-oriented language. In object-oriented languages, types are very important. For C, it doesn't care about the types. So how can you satisfy both worlds, okay? The answer is no, you can't. Okay, that's why C++ is not like C, very low-level language, or it is not a pure object-oriented programming language. But they struck the balance in a nice way, and that's why people like it a lot. Yes? C functions. C. Yeah. Well, if you don't put any types in there, right? You are turning off the type checking, basically. I mean, to be able to use printf in C, to be able to use printf, what do you need to include? Include what? stdio, right? stdio. I bet some of you forgot including stdio and printf still works. Anybody realize this? If you forget this, and printf still works. Because in C, if you are using a function that doesn't have any prototype, that is not defined, it assumes that it's a function that returns an integer, printf returns an integer, and that function is defined like this. Well, the meaning of such a prototype for C is, okay, this function is going to return an integer, and it can take any parameter that it likes, okay? There is no restriction. And printf is kind of like that. That's why it links and runs, okay? In C++, no. If you don't include the header file for a function, then it will give you a error message at this line. It's going to say that I don't know this function. I need a prototype. I need a definition for this function. That's why C++ is not exactly backwards compatible with C. You cannot use the C++ compiler to compile all the C programs. But if you like to make this conversion, port your C programs to C++, it is easy to do, make some modifications, but it is not perfectly compatible with C. Okay, let's move on. Assignments, shorthand notations, data assignments. We don't like mismatches when we do the assignments. If you are saying that I have an integer name is variable and you are trying to initialize it with 299, well, I mean, you might say, well, I did it, it works. I did it, it works is not a good explanation for anything, okay? Compiler, the fact that the compiler compiles something, well, it is nice, it is better than compiling, not compiling, right? Doesn't mean that what you are doing is right, or doesn't mean that you know the rules right, okay? Compilers are pieces of software, and they have their own bugs. Sometimes your compilers might crash, okay? Sometimes they compile your program wrong, and sometimes they may not obey the C and C++ rules, okay? The fact that this initialization works doesn't mean that it's a good thing. Don't initialize your integer with a double. And in fact, don't do this. If D is a double and its value needs to be 2.0, don't write this. Write this. Okay? It is okay for the compiler if you write this too. The compiler is smart enough to make a temporary double 2.0 and do this initialization. But the better thing is, I know what I am doing as a programmer. I know D is a double, and I am initializing it to 2.0. Okay. By the way, this is not an assignment. This is initialization. Initialization is very different from assignment. Okay. For C, maybe it doesn't matter assignment or the initialization. For C++, it is very, very different. The mechanisms are very different. Maybe you can. Which one would you prefer? Integer I, or I gets the value of 2, or integer I gets the value of 2? Well, in effect, these stuff are the same, right? Get me an integer and make its value 2, it's assignment. Or I am declaring an integer with an initial value of 2, right? We prefer this one. It both initializes and declares it. This one, it initializes first, then makes an assignment later. Maybe for the integer it doesn't make a much difference, but for other stuff that we are going to do with C++, it is very, very different. Okay? Any questions? Yeah.
Why we should write 2.0, for example.
2.0? That's the software engineering discipline, right? If you write 2, it is okay. The compiler will compile. The result will be exactly the same. But when you write this, double D initialized with 2.0, that means that you know that D is a double, and you're initializing with a double number. That's the rule of programming. If you don't obey it, yeah, that's fine. The compiler will compile, your program will run. But what is the rule? Rule says that type mismatches don't use mismatched types in an assignment or initialization. Okay? That's the rule. That's the rule of programming. Okay? Maybe.
Around is more important.
What?
If we assign integer
To a double?
If we assign double to integer variable, it should be problem, but
well, as I said, I did it, it works and it compiles and it runs perfectly is not a good explanation for anything, okay? These are the rules that we follow. Object-oriented programming, as I said before, you don't need object-oriented programming to write nice programs, to running programs, okay? Perfect programs. C is fine. Even assembly is fine, okay? But as human beings, we cannot write our programs in assembly. It is too low level. And we say the same thing for C too. C makes writing some programs difficult for us as human beings. Object-oriented programming will give you a set of instructions. Follow these rules. Do this and this and this and this. And if you follow those rules, and experience tells us that your programs will turn out to be much better than our C-style programs in terms of maintenance, in terms of testing, in terms of finding what is the problem, okay? So it's a discipline. You don't have to follow this discipline. You don't have to be an object-oriented programmer. I'm just showing you telling you the rules. And you might say that what is the rationale between under this rule? Don't do the mismatching. Well, it is not that easy for me to give you why we are doing it using only integers and doubles. But when we start learning about or making our new types, you are going to understand what I mean. Okay? And generalize it and do it that way. Some people say that, well, nowadays we don't do it that way, okay? How many people make this mistake and spend 2 hours to figure out what's happening? If, then do this. How many people who you did that? Okay, you are the most brave one. I bet half of you did. If you didn't do this mistake, you are not a good C programmer. I'm serious, okay? If you didn't do this mistake, you are not a good C programmer. Or let me do it this way, okay? I make this mistake and it works, it compiles, it makes this assignment, A gets the value of 7. Since 7 is non-zero, it always gets into this, and etc., right? Doesn't matter what the value of A is. The correct version is A is equal to 7, right? Some people say that whenever you are comparing a variable with a constant, don't compare it this way, but compare it this way, okay? If you write it correct, what is the difference between is 7 equal to A or A equal to 7? It is exactly the same thing. But for us humans, we make these kind of mistakes. So if you make it a habit for you, okay, always write your equality statements, is equal to statements this way, then if you forget about this first equal to sign, then the compiler will give you an error message, right? Okay, you are not machines, you are humans, and you are going to make these kind of mistakes. Okay, you are going to make these kind of mistakes. Again, these are all they will come from experience, and these kind of rules are set up by the experienced programmers, software engineers. They say that let's make this a rule, and that's going to be a nice rule. Okay, it's like living in a social world, right? We follow some rules. Okay, whenever you see somebody that you know or you don't know saying good morning, merhaba, etc. I mean, why do we say so? I mean, why do I have to say merhaba to somebody that I don't know? Okay, it makes you feel good. It makes him feel good, and that's the rule. That's kind of being polite, right? We try to be polite in a social world, not maybe in Turkey, but most of the part of the world, we try to do it that way. That works. Human beings figure that out, that if you greet somebody that you do know or you don't know, it works. But you don't have to, okay? Nobody's going to tell you that you didn't greet me in the morning and you are going to be jailed for that one. No, we don't. It works both way, but greeting the other people is better. I don't know what I am talking about, but yeah, this is C programming. Greeting people in the morning is C++ programming. Let's take 10 minutes of break. Where is my attendance? Can I have the attendance sheet? And we will continue from that time. 10 minutes.
Hocam yoklama imzalayabilir miyim? Sen imzaladın mı? Yok. Hocam bir şey sorabilir yanlışlıkla. Hocam yoklama imzalayabilir miyim?
Ben değil mi ikinci de söyleyeceğim diye.
Hocam ototipinde fonksiyon
Arkaya
oluşturabiliyor
oturun.
muyuz?
Şu tarafa oturun, oradan devam edin. Efendim?
Ototipinde fonksiyon oluşturabiliyor muyuz? Hani return value'yu direkt belirlesek algılar mı yani?
Ha, fonksiyon ne return ediyorsa oradan.
Evet.
Yok, olmuyor abi.
Devam mı edecek?
Yani çünkü fonksiyon bir yerde bir şey return etmek zorunda değil. Birkaç yerde return ediyordur. Bazen integer, bazen de double return edebilir. Hani
İşte o durumlar için
evet ama sakın. Bir denesen onu sen, belki oluyor.
Tamam.
Yani sadece bir yerde return etsin. Bir de birkaç yerde return etsin.
tane alıyorum ama bir daha alamıyorum.
Enflasyon. Geçen de 30'a aldım.
Taşıyorsun ama. Boş boş taşıyorsun. Neyse. Ha, perde mi var lan burada? Perde mi?
Kilo. Biraz da kilo var.
Ha.
Nazar değil. Oynar değil. Neyse.
Evet.
Daha demin dedim de anlamadık galiba. Şimdi arkadaşın üstündeki kişi galiba bir altına yazmış arkadaş yerine. Biz onu sildik. Kuş kalem yazmış. Ama o kendisi yok yazacak şimdi. Onu ne yapalım?
Kimmiş o?
Ya biz öyle sanıyoruz. Sen kaçıncı sayfadaydın? Şuydu arkadaş. Bunun ne olduğunu tahmin ediyorum. Şuraya yazmışsındık zaten.
Hangisini sildiniz? Ben görmüyorum şimdi.
Şimdi arkadaş bu buraya yazmış. Rabia Budak buraya yazmış galiba. Onu sildik. Kendi imzasını attı. Kuş kalem atmış.
Tamam.
O yok yazıyor.
Rabia mı yapıyoruz?
Ha.
Rabia burada mı? Rabia Budak?
Herkese gelmemiş.
Rabia Budak burada mı? Sen imzanı yanlış yere atmışsın. Emre Yavuz'un yerine. Gelme, gelme oradan at.
Aklım orada kalıyor.
Furkan Baran burada mı? Furkan, niye 2 tane imzan var senin? Niye 2 tane imzan var? Ya bir de bunlar birbirine de benzer, üstüne karaladım tamam. Hiç akıyordur.
Alayım mı kağıt?
Nerede kalmıştı imza arkadaşlar?
Keşke. Yok, toplama yok. İçerisini imzalayamayım da arkaya geçeyim orada oturayım yani.
Oraya otur. Derse de zamanında gel bundan sonra.
Tamam, Express hızından biraz bir sıkıntı oldu da. Hadi yeter yeter.
Okay, so compatibility of data assignment is, I mean, we used to teach you rules about when you do the data mismatch in the assignments. What's going on? We started, people. Okay. When you do the assignment, if you make sure that the left and right sides of the assignment operator is the same type, it would be good for you. Otherwise, compile is going to make a decision, and sometimes you don't know what that decision is. So always try to do this assignment. If it's an integer, then do it an integer. If it's a double, then do it as a double. We have constants as in C. Two types of constants. One is the literal constant. Okay, these are the literal constants. 2, 5.75 z, and etc. Okay, and the other type of constant is named constant. And we are going to see the other named constant. These are literal constants because you are literally typing them, right? You literally type 2, okay? You literally type 5.75 and etc. Okay? So what is the type of this 2? What is it? Is it, tell me the type, the variable type of this 2. How did you know? How do you know that it is not a long or short?
Yes, it's right side.
What?
We assume it's right. What?
No, there are rules for. How about this one? Is this a float or double? How do you know?
If f suffix, then
Yeah, if you say 5.7f, it becomes a float, and in fact there are rules of literal C constants. Okay, let me show you how for each type there is a way of writing it, but I don't have it in here. Let me find it. Where is it? C constant literals. Should I click? Oh, okay, maybe IBM is better. Okay, good. So this is a decimal integer. This is octal, hexadecimal. These are all integers. See, this is an unsigned integer, constant, literal constant. This is a long constant. This is a unsigned long constant. Okay, and these are floating point literals. Okay, this is let me show you where are. Okay, these are string literals. This is not a good site. Maybe go to IBM.com, and it's going to be. I like to find a table that shows you all types of literal constant ways of writing it. Yeah. Couldn't find it. Constant and literal types, not Visual Basic. Oh, okay, because. Okay. Am I back to the same place? Well, I think this is good enough then. For the doubles and the floats, if you put an F at the end of the double numbers, the literal numbers, then it becomes a float. Why is this important? Because remember what we said? We said that do this right, okay? When you do this, for example, if I have a float f, when you do 1.27, you are assigning a double to a float, okay? So make this 127f, okay? So now you are initializing a float with a float, okay? So there are ways of writing literal constants, and this is a literal constant character, and this is a literal constant string, okay? So literal data is here, and there is nothing new about, yeah, this is an integer, this is a double. By the way, yeah, let's look at, I think I didn't look at, these are how you, this is how you write integer literals in different ways, okay? This is decimal integer literal constant, okay? Well, this is decimal, this is octal. Did anybody make this mistake? When you start writing an integer with a 0, it is of base 8. It is octal number. It is not a decimal number. Okay? For some reason you might have done that, and that's going to be a lot of trouble. Okay? This is not 213. Okay? This is of base 0213. Okay? This is hexadecimal, integer, unsigned int, and etc. I think there is a way of writing numbers in binary in C and C++. Literal binary numbers, can I literal C binary integers? Can I write them? Yeah, maybe this is better. C++ reference. Integer literal, these are okay. Decimal, octal, hexadecimal, yeah, binary. What? Oh, C++ 14. Not 11, but 14. Okay. What is this? Unsigned long, double long, this one. And after that, we have, what are these? Same value. Did you understand what this is? 744. Oh, I am writing them in clumps on by 3. Oh, I am writing them so that it is easy to write. It is easy to count how many digits I have. 1, 2, every thousandth I have this code thing. So it is available after C++ 14. And I can do that too. Very interesting. Anyway, did I mention that C++ is a very complicated language? And it is so complicated that nobody knows the whole language. Every time you need to do something, you need to look up the reference menus and etc. There is no way that you can learn the whole language in a short amount of time. But experience will tell you that you don't know all the details of the language. You know the crucial ones, of course, but you know how to get to the details. Okay, you know how to look up in the at the web. Usually this kind of sites, C++ reference, c++.com, they are good starting points. Okay, so don't forget about this. This binary literal constant is available starting C++ 14. We have the decimal, octal, and hexadecimal. Okay, good. So this is how you write the literal constant data. Of course, you cannot change the value of 2. The value of 2 is 2. You cannot change it. That's why it is called literal constant, because you are literally typing them. Escape sequences are available, and it is the same thing. \n, \t, \r, \\. You know the meanings of those. Maybe they have spent like a week to tell you what the escape sequences are in your C course, but I'm not going to talk much about them. They are important, but I'm not going to talk about them. C++ says that I will introduce a new row string literal constant mechanism. This is a string. It's a string. It starts with an R and code. Okay, this is literally code parentheses \t \\. So all the regular meanings of backslash and quote are all ignored. So the value of this string is exactly this, including the quotes. Okay. So it is useful for the while names. Remember, in Windows, in DOS, we use the backslash character a lot. In Unix, we don't have that problem. For the file names, we use the regular slash division operator kind of sign. For the DOS environment, Unix environment, Windows environment, we use the backslash. But backslash is a different meaning in C, C++. So not to get confused about that, maybe you can use this type of row string literal that is introduced with C++ 11. Okay. The second type of constant is the named constant. You say that I have this identifier, okay, its type is integer. Its initial value will be 24 and it's a constant. I don't want to say constant variable and constant, they don't come together. It sounds funny, constant variable. We call these type of variables named constants, okay? This is a named constant, okay? It is constant because you put this const keyword at the beginning of the declaration, saying that I am initializing this, okay, integer with 24, and nobody's going to change it. If somebody tries to change it, then give me an error message. Okay? So you are telling the compiler that nobody's going to change it. So if nobody's going to change it, why we put this keyword in here? So that I prevent myself or somebody else from making a mistake by mistakenly changing this value. Okay? So the same question that you ask actually. You ask me what is the difference between assigning it 0 and 2 and 2.0. They come to the same thing. But I mean, if the program is right, putting this const keyword in there doesn't make any difference. Okay? But if I put this const in there, I am applying this principle. Okay? What did I say? Object-oriented is a set of object-oriented program is a set of rules. It's a set of principles. One of the principles is principle of least privileges. Always try to restrict yourself. Okay, least privilege. So I am taking the privilege of modifying this variable from me or from my customer. Why? Because you don't need to modify this number of students. It should not be modified. If it is modified, then give me an error message by the compiler. Okay? So this is the application of this rule, principle of least privilege. If you are a very smart software engineer, you don't make any mistakes. Okay? You are not like regular human beings. You don't make any mistakes. Then you don't need to use const keyword. Okay? You are perfect. Then in fact you don't need any object-oriented programming or C programming. Write your programs in assembly. That would be perfect because you are perfect and you are not making any mistakes and you remember all lines of code in assembly, millions of lines of code. You know where it is. So in fact you don't need any functions. Okay, so that's good. But there are no human beings as far as I know like that. Okay, we all make mistakes, and object-oriented programming is something, a discipline that tries to limit these kind of mistakes that we do, either in the design phase of our software systems or the implementation phase or programming case or the maintenance or testing case. Okay, so I'm going to give you these kind of rules one after the other. Some of them will make sense, some of them will not make much sense. But as those are the rules, and I am sure at the end of the semester, most of those rules will make sense. Okay. Some people say that why are we using this in C? We have this nice define statement, right? Instead of number of students, okay, I have a program like this. Let's look at this program. It says I have a constant double rate. Initial value is 6.9. Okay, it does some calculations and it prints something at the on the screen. Okay, so it's not important for now what it does, but instead of doing this, why don't I just here define rate 6.9? Isn't that the same thing? C++ says that no, don't use defines, use this constant named structures. Okay. Yeah. Are you going to? Yeah.
To use the same name in another scope.
Well, yeah, that's a very good reason to use constant keywords. Maybe rate is a constant in this function main, but I am going to use this rate. I am going to use this rate for another variable, maybe not constant variable, in some other part of the program, right? So that's one reason. But I can use this define. I don't have to define rate at the beginning of a program, okay? You can define it just before the function that you're declaring. Later you can undefine it too. So I can kind of work around it. Well, that's, you might say that looks ugly, define it, undefine it. Yeah, that's true, but there are other reasons why we are doing this. When you say define rate 6.9, okay, what is the meaning of it? It says that the preprocessor says that wherever I see a rate, for example here, I am going to replace it with 6.9 with a literal constant, right? Okay. Well, it turns out that this literal constant is a double, and I need a double in here. So the compiler has to figure out the type of it, okay? But when I do this, I am saying that rate is going to be a double. It's a constant, but it's a double, okay? This one doesn't give any explicit types, okay? I have to be careful about what I am defining here. But you might say that if you like to define a float, maybe you can do this too. Yeah, that's true. But why don't you use the regular, more understandable constant, float, rate, etc., right? So this is better than defining. Well, where did it go? Okay, this is better than defining. The other thing is, one final thing. We don't like, preprocessor is a good invention by C, but it is an invention of 1970s. C++ is a much more modern language from 1980s. There is a drawback of using preprocessor in programs. How does a program? Did anybody? This is 21, right? Let me go to the beginning. Did anybody try these switches? Especially this one. Anybody tried it? So nobody was listening yesterday to me. I told you that test whatever I told you after the class at home or in the lab. Nobody tried these. What is minus e? Minus e is this. C++ minus E. What was the name of the program? 01? Oh, okay, CPP. Oh, this is too much. Okay, let me try to. It is dumping lots of stuff. Let me try to redirect it to out.txt. Okay, it produced something that is 666 kilobytes. What is it? Less out. Okay, can you understand what it is? It is C++ code, right? Lots of definitions. It still goes on. Let me show you the last part of it, tail of it. So this is the last part of it. It looks like the last part is our program, right? So can you guess what this is? Out.txt.
It exported all definitions in the library.
It's what?
Exported all definitions.
In other words, it is a pre-processed version of our program. Remember what does what the preprocessor do? It includes all the files. It pastes whatever. Okay, let's see. Okay, preprocessor takes this statement. They say that IO stream. It finds the IO stream header. Whatever inside that IO stream header, it pastes all the data, all the lines into my file. So my file, instead of wc minus l 01 cpp, my file is 20 lines long, but out.txt is 28,000 long. The compiler, in fact, compiles a program of size 28,000 lines instead of compiling 20 lines. Okay, compiler gets this file. So preprocessor makes my file, C files, a lot larger, right? So why all of a sudden I started talking about this again? The first point is, you're not doing what I am telling you to do. Try these at home, okay? That's one thing. I am surprised that even a single person, I hope somebody tried it and that person is shy. He tested it, but he's not, or she is not telling it to us. What happened to my, okay, here's it. Okay, that's one thing, try it. The second thing is, this is a preprocessor directive, okay? It's going to replace all the rates with 6.9, wherever it sees it. The compiler will not see the name of rate at all, right? So if there is an error about rate, compiler will give me an error message about 6.9, not about rate. So that's going to confuse me too. So stay away from the preprocessor. Of course, we have to use the includes. We can't do anything about that. But other than that, don't use defines. Don't use that kind of preprocessor tricks that we used to use a lot in C. Instead, use this kind of C++ ways of doing stuff. Okay, so I spent like 15 minutes to explain why we are doing this instead of doing that. Why is that doing it? Maybe I should use two fingers. One finger is bad because it is, oh no, it is good. Okay, maybe I should use one finger. Okay, good. Any questions about this named constants? Okay, again, two type of constants, literal constants and name constants. These are literal constants, and I showed you how to write literal constants, and these are named constants. We prefer named constants. Of course, this has to be a literal constant here, okay? And use this type of, I did the same mistake again. Can I go back? No. Okay. use this type of declaration instead of this type of declaration. Don't use any defines. Okay, let's look at this program. Very simple, stupid program. Most of the programs are going to be simple and stupid, not useful in real life. But if the program is small, but there is nothing much you can do. Okay, let me get rid of this type. Okay, I have a name constant rate, a variable deposit. Okay, a variable deposit. Question for you. This variable deposit is stored somewhere in the memory, right? Somewhere in the memory. Do I store that rate somewhere in the memory too? Yeah. 6.9? Does it make any sense to store that 6.9 anywhere in the memory? Yeah.
For giving error you mentioned before.
But the errors are during compile time. I am talking about runtime. Compile time is very different than the runtime. During the runtime, there is no compilation error. Do I store the rate 6.9 somewhere in the memory while the program? I have to keep some place for deposit during the runtime, right? Otherwise, how am I gonna modify it? But since this one is a constant, okay, maybe I don't have to store it anywhere in the memory. Well, it depends on your optimization flags, okay? If you don't optimize your code, maybe it is stored. But if you optimize your code, compiler is smart enough to replace all the rates with 6.9 and use it directly, okay? That would be much more efficient, right? Directly using constant without referring to the memory space of the rate. Okay, so I have this rate, I have the deposit, cout, a stream insertion operation, and stream extraction operation. Deposit is double. Okay, this operator is smart enough to know that I am going to read a double from the keyboard, from the standard input. Okay, that's the thing. And then I define a new double, new balance. I can do this in C++, but not in the older versions of C. In C, whenever you write a function like that, okay, at the beginning of function, you make your definitions, your doubles, your integers, and etc., and you write your code, right? This is how they told you about writing C functions. At the beginning of your scope, okay, at the beginning of your block, you declare your variables. In C++, from the beginning, from the first version of it, you can define your variables anywhere you like. Okay, you might say that, okay, I tried this in C, it works. Yeah, for the newer versions of C++, it is available, but usually we try to write C programs in a way that even the oldest compiler from 98, okay, ANSYS standard, can work. Okay, so new balance is another double, and I am saying that my new balance, of course, this is a stupid banking application. My new balance is going to be deposit plus deposit times rate over 100, and I don't like this statement like this. It should have been 100.0 like that. Okay. Rate is a double. 100 should be double too. You might say, what's the difference? I mean, compiler is going to make a new temporary double whose value is 100.0. No, don't do that, okay? If this is a double division, always use doubles. This should be double and this should be double. Okay, so I am saying that divide this rate by 100.0, multiply it with deposit and add it to deposit, and that's going to be your new balance. And print it out on the screen. See, I am saying what I am doing here is I am printing a string, then another string, then a double, then another string. It is, I think it is readable than a printf. I don't have to think about Am I printing a double? Am I printing a string? Am I printing a character? Okay. It could have been just a character too, like that, and it's going to work. C out is smart enough to know the difference between a string and a character. It knows how to print all of those. Okay, so when you run the program, give me the value of your deposit, and in 1 year your deposit will grow to this much if the interest rate is this much, 6.9. Yes.
I have a question from the previous slide. You said if you optimize your code, the constant value you want to store in the memory, is it stored in the executable?
Yeah, if you optimize your code, there will be no place in your memory that is reserved for rate.
If it is used multiple times in the code,
Yeah.
there will be multiple instances in the executable.
Yeah. It will, because if you try to visualize the assembly code for this one, wherever the rate occurs, is going to be a constant being loaded to some register, right? If I store it in the memory, then I need to go to the memory, and I need to get that value, and I need to place it in a register. But if it's a constant, then I can directly write that constant to my register. Okay, load this value to the register. Oh, you might say that where do you keep that constant? Well, it is in the memory, but at least you don't have to go to some memory address to find the value of that rate and etc. Just try it. Okay. Try it. How do you try it? Can I try it in here? No. Well, you try it. Just write a get rid of this C out and C in. Okay, because these will make it complicated. Get rid of this one too, and get rid of this include statement too. Okay, so it is a very simple program now, and optimize it and look at the result to see in the assembly version if you have any reserved space for rate. Okay, you would find, I guess you would find that rate is defined as a constant in the assembly too, not in a specific space. Okay. By the way, C and C++, they are hackers' languages, right? There is a way of taking away the constantness of a named constant. You might say that I am going to change the value of this rate. I know what I am doing. Take away the constantness. So it's called constcast. Okay. In that case, of course, if you are going to change its value, compiler has to put this in a memory location. But that's hacking stuff. Arithmetic precision. Well, I mean, you know all of this stuff from the C course, and you know the difference between this operation and this operation are two very different operations, right? This is an integer division. This is a double division. Okay, integer divisions operate differently. The value of the 17/5, okay, is not going to be 3.4. Okay, it is simply 3. It is simply 3. The value of 1/3 is what? What is 1/3? 0, right? It is just 0. It is not like 1.0/3.0. This is not 0.0, but this is definitely 0. These are two very different operators. That's why I say this is overloaded. Okay? That division operator is overloaded. It behaves differently in this case, and it behaves differently in this case, like 8 left shift 2 is very different from C in I. Okay? It is overloaded, and you should know the difference. You should know the difference. Integer division and double division. What is the rule? The rule is If both sides are integers, then do the integer division. If there is a type mismatch, which we don't like, but if there is, then try to promote one of the operands to the higher level operand. Okay, since integer is a lower level operand than the double, so produce a temporary double that is in value that is equal to this 5, which is going to be 5.0, and do the double division. When you do the double division, we will get a double. Okay, so we already know that. I think they told you about this kind of stuff. Okay, this is, I mean, don't write any expression like this. Whatever you write, it should be easily readable and understandable code, right? This is not readable or understandable. Okay, then you might ask, why are you asking this kind of question to us? Well, I am not asking because you are going to use this kind of stuff in real life, but these are good examples to understand what's happening. Okay, so this one says that, okay, we know that the precedence of these divisions are the same, so we are going to look at the associativity rules. Associativity of the division says that left to right. First do this division, 1 over 2, it's an integer division, it's going to produce a 0, right? It's an integer division. So then I'm going to do 0 over 3.0, it's going to be a double division, but if you divide 0.0 with 3.0, it's going to be 0.0, then it's going to be 0.0 over 4, again a double division, and it will produce 0.0. Surprise, surprise, but as I said, don't write this kind of stuff, 1 over 2 over 3 over 7, etc. Okay? Nobody's going to understand what you are doing, and even you will confuse yourself too. But again, it's important to know what's going on. Typecasting is there. I mean, when I say always use the same type expressions, including the assignment expressions or the other type of arithmetic expressions, but from time to time, I need to typecast from one type to another type, right? Okay. Sometimes I need to typecast it. In C++, we do typecasting this way. There is an operator called static cast. Okay, that's the operator. In this case, the static cast, okay, in this case, the static cast will convert this integer to a double. Okay, of course, I'm not talking about converting this specific integer. I'm saying that it's going to produce a double number in value that is equal to this integer. That's called static cast. Okay, that's called static cast. In C, maybe we used to do it this way. Double D gets the value of double I. Maybe I is an integer, right? In C, we used to do this, right? In C++, we don't do it that way, okay? In C++, we say static cast. I am casting this integer, okay? Or I am casting this the static cast double and I. Okay, that's how you do typecasting in C++. We don't like this anymore. We like this. It works, but we don't use it. Okay. This is more readable. And when you do Control F, search for all the typecast in a file. Okay. You just look for this keyword, static cast, and it will tell you all of them. Okay. When you might think that if there is a static cast, maybe there is a dynamic cast too. Yeah, there is a dynamic cast, but for that you need to wait maybe 6-7 weeks, maybe after the midterm. I'm going to teach you about the static cast, and there is a const cast which takes the constantness away from a constant, if it works. And there is a fourth type of cast. I forgot what was it. Okay. So this is how we do the typecasting in C++. We don't like casting. Okay. Originally everything should be in the same type, but if you have to, then this is the way to go. Where is my attendance? Attendance? Just send the attendance. Okay, bring it. Yeah, thank you. Any questions? Okay, that's it for today. Tomorrow we will continue from this point on. And by the way, I forgot my microphone. I hope it worked.
Bundan numaram çıkmadığı için ben ismini yazarak imza attım. Bir de yarım